evening all of you. Today we are going to see an important topic called Avalanche breakdown and Zener breakdown. So both these breakdown occurs when a PN junction diode is reverse biased. So now you have P-type material and N-type material. P is connected to negative and N is connected to positive. In P-type material, electrons are the minority carrier. In N-type material, holes are the minority carrier. Now what happens is, this is the depletion point. When the reverse voltage increases, this depletion width will increases. So that is the starting point you have to remember. So when the reverse voltage increases, this depletion width will start increasing. So velocity of minority carriers will increase. Velocity of the minority carriers means in P-type material it is going to be the electrons, and in N-type material it is going to be the holes. Okay. Now since velocity of minority carrier increases, the kinetic energy will increases, because we know that kinetic energy is equal to half mv square. So v square, v is nothing but velocity. Okay. So this will increase. So when this velocity increases, kinetic energy will increase. So this what it will cause, number of collisions will increase with stable atomic structure. That means that inside this P-type element and N-type material there will be stable atomic structure. Because of this minority carriers, they will collide with the stable atoms. So when the stable atoms is collided with these minority carriers with this much of energy, which is given by half mv square, what happens? The valence electron gets released from the parent structure. That is, this means, suppose if you have an electron, when it bombards with this energy, so this electron gets released. So when electron is released, this point will become positive. Positive in the sense it becomes hole. Now similarly it happens with the entire stable atoms. So what will happen? This will release more number of electrons. Electrons in the sense, in P-type material it is electrons. So it will release electrons. Similarly in N-type material, the number of holes released will be more. So this is a cumulative process. Cumulative process in the sense what? First an electron is released. I am considering P-type material. Minority carriers, there is electron. So that electrons released from the stable parent structure tries to bombard with next atom, stable atom. Now this what will happen? Their electron gets released and that will bombard with some other stable atoms. So likewise at the same moment many collisions will happen. So this is a cumulative process. So finally what will happen? Since number of collisions will increase with the stable atomic structure, valence electron leaving the parent atom also will increase, because more number of electrons are released, minority carriers are released, and more valence electron will come out of the parent atom will also increase. If that increases, then avalanche current will increase. The current avalanche current will increases, which results in the avalanche breakdown. So these are the steps you have to remember. So forward bias, it will act as an ordinary diode, that we will know. So in case of silicon, we know that this is going to be 0.7 or 0.6 roughly. But when reverse voltage increases, the depletion width is going to increase. So what happens is, there is small leakage current, we call it as IS, that is called as reverse saturation current. So when more reverse voltage is applied, so it's this gap, reverse saturation current will also increase, and these steps will occur, finally results in the avalanche breakdown. So this point we get a avalanche when there is a sharp rise in the current. There is no further increase in the voltage. Even if you try to increase the voltage, it won't increase, and there is a sharp increase in the current. So that is called avalanche breakdown. And when a device, a PN diode enters into that region, the device is likely to fail. This is one point. Now coming back to Zener region and Zener breakdown. What you can do is, this P-type material and N-type material can be heavily doped. If you heavily dope, this region can come close with this voltage will increase and current will increase, and the breakdown can happen somewhere here. If it happens like this, then we call it as Zener breakdown. But what is the difference? Here the breakdown is due to electric field. Electric field means heavily doped P-type material and N-type material. So between this distance there is a depletion region. So electric field is volts per meter. So it cannot handle that much of reverse voltage. So there will be a breakdown due to electric field. So this word you have to write. So Zener diode occurs because of strong electric field and thereby the breakdown, and there is a sharp increase in the current. Whereas in avalanche breakdown, what's the difference? In avalanche breakdown, minority reverse voltage increases, velocity of minority carrier increases. So this is a mechanical event. Therefore kinetic energy increases. Kinetic energy, the number of collisions will increase, and this will bombard the stable atomic structure, and more electrons gets released. If more and more electron, it becomes a free electron. Therefore it will start, the current will rise very hugely. That is called avalanche current. A very big current will flow, and that will result in avalanche breakdown. Okay, that's the difference between avalanche breakdown and Zener breakdown. Hope you have understood this topic about avalanche breakdown and Zener breakdown, and the difference between these two breakdowns. One happens with the mechanical event, especially the velocity, thereby kinetic energy. Another one is due to the strong electric field. Okay. Thanks for watching this video. Nandri.